Hello, here we are again up to the crankshaft of the air engine. All right. When we do the crankshaft of the air engine, we're going to need a lathe and a mill. All right. The lathe that you're going to be introduced to is a lathe. It's called a tool room lathe. It could run manually or conventionally and CNC. Okay. You'll be using it in manual capacity. All right. So I have it turned on already, so it booted up. The on button, okay, the on button up here, top left green button is the right button. The only button that we don't have in our shot. All right. Okay. But once it's turned on, all right, then coming back over here, we shut this door because there is a switch on it. And then over here, I like to call it the detonator because it's on a cord hanging from the side of the machine. All right. When the machine's running fully automatic, the operator needs to hold this button to make it run. All right. But you hold this button like a detonator. All right. And you hit the power up restart button. You'll see the machine starts to hum. Notice these hand wheels are turning by themselves. Those hand wheels are running the home routine. All right. This is the X axis. It backs up first. All right. And you'll notice this black knob right here. You got to make sure this black knob is not going to come in contact with the edge of the door. All right. You got to watch that. Machine doesn't know that knob is there. X stops, and now Z. And you can see how slow. You can see how slow this routine is. All right. You can return these handles pretty much all the way back to home by themselves, and then press home, and it'll happen much quicker. All right. So while this process is happening, we're going to pause. Okay. Are we recording again? Yes. All right. Okay, so now the machine has been homed. All right. So we are going to first select the settings and graph button, and then you'll page down one, and then you'll cursor down to setting 51. Setting 51 is called door hold override. And then you can hit the left or right arrows to turn setting 51 on. Then you need to press right. Okay? When you hit right, the screen will now display you have selected a less safe operating mode. There's an increased risk of operating injury, all right, with the door open. All right, we're not running the machine in automatic mode. We're running the machine manually. We say yes to this. Okay? All right. So after you've done that, you go back to the hand jog button. Did I say that clear enough? That's the hand jog button. All right. The hand jog button has been depressed, and we see manual mode. All right. We need to press right. All right. Now we're 100% ready to go. Okay. I'll open up the door. Now we've got a treat this semester. I've got enough brass that we could use brass for the crank disc, not steel. All right. So you get a nice brass crank disc for your flywheel. All right. 3-jaw chuck is a little bit stiff. Got it moving. Okay. Now, notice that I put a pretty good bar stock in the machine. All right. I'll cut the bars and bring them to the machine as you need them. This crank disc is so thin; it's only 1/4 of an inch. That I don't want you chunking off 2 to 3 inches of brass just to make a 1/4 inch part. And so we're going to use a process called parting off. Everybody should know how to part off an item in the lathe. It's a procedure that you do all the time. So this is going to be your opportunity to experience a part off routine at the end. Okay. All right. So I will bring the machine up manually. The tool that I'm using here, I should show you real closely the tool that I'm using here. All right. It's once again an Alaris tool holder, but this tool has enough relief angle on both sides to do a turn and a face, or I should say a face and a turn, without changing the direction of the tool. Okay. So over on the mills, on our previous projects, we were using an edge finder to find an edge. Okay. Ultimately, that edge, that 0, was becoming an origin. Well, now we have a real origin. All right, we got a real origin on this machine. We have a couple different coordinate systems that could be utilized. You'll see over here that right now it's saying it's the machine's coordinate system. Okay, the machine's coordinate system is an unshifted coordinate system. If I page up, I can find a distance to go. My distance to go indicator, a work coordinate system, G54. G54 is the work coordinate system that is being utilized on this machine. The G54 work coordinate system is set so that 0 is aligned on the center of the part for this Jacobs chuck, because this lathe does not have a tailstock. So we have to use this Jacobs chuck on a Alaris tool holder set on the Alaris tool post. Okay. What we need right now is the operator's coordinate system. We have the operator's coordinate system active. The operator's coordinate system is what we'll need. When the operator's coordinate system is active, anywhere the machine is sitting, you press an X and origin, and the axis goes to 0, like setting a 0 on the manual DROs of the manual machines, or a Z origin. Okay, so we're starting with 1.25 inch stock, and we only need to take it down to 1.2. That's only 50 thousandths off the OD. All right, so that's a very nice light cut. All right, so what I'll do here is I'll start the spindle. I'll type a 500 and spindle forward. We'll run the machine at 500 for this. That's a little bit of cutting. All right, I come up, I find the edge of my part with the cutter. I turn my cutter in so I'm not running an interrupted cut. And then, notice on the screen here, it says XZ manual. All right, that means I could use the handles. If I type my axis indicator buttons right here, an X or a Z, that axis will go into automatic control. That'll allow me to use this handle. So I'm going to type a Z right now, all right? And I'm going to turn my stock. Let me reset my 0. All right, I'm going to go Z origin, and I'm going to proceed down. I only have to go 1/4 of an inch. So I'm just going to go to watching my indicators now. My tool is set. I really don't even need to look at it. I already set my tool. Turning down to 250. Now you can go past it a little bit. It's not going to hurt. All right. But you don't want to go way past it because you're just going to use up too much stock. And guess what? I did forget to face it off first. So I'm going past 250. Sorry, I want you guys to face off first. So I'm going down to 300. That way I can come back and face off 50. All right. I come back to the 50 mark in Z. Then I switch to X and I run it into the center. I'll stop my spindle with the stop button. All right, so that is all I needed to do. All right, now I didn't even follow my own procedure. All right, but I saved it. Okay, so once you do learn how to use these machines, you're going to learn that Kev's way isn't always necessarily the only way to run a machine. Okay, and this actually really worked well for me. I found my edge. All right, I went in my 300. Okay, got it down to, took 50 off the diameter. Then I came back and I just took 50 off the face. And it was one cut, just like that. All right. Now with that out of the road, I'll back the machine up. I'll put my Jacob's chuck on. Locking it down, locking the Lars down. Putting my center drill in. Number three or number 4 center. All right, pausing. Lost the camera. All right, we are back after our camera fall. All right, here at Mickey Mouse U. All right, so we're going to change our operating system. I read the word operator. I said operating system. All right. I'm going to change my coordinate system from the word operator to the word work. G54. Okay. G54 is the work coordinate system that we need. Now I can't reset these numbers. I got to go to it's 0. So I'm going to type an X and I'm going to move the X axis to 0. All right, 6/10,000ths of an inch. All right, next pulse will go right past it. Boom, to negative 4/10,000ths of an inch. And that is because my multiplier. So I got to reduce the multiplier of my handle. I do that with this row right here. All right, so I go to 1/10,000th and I can dial in my exact 0. Okay. Okay, so now I am going to, all right, while we were at Paul's, I've finished tightening up with the chuck wrench, okay, the Jacob's chuck wrench, tightening in a number 3 or number 4 chuck wrench, okay? I'll start the spindle back up. I want you to do the drilling manually, all right? I want your hand on the Z hand wheel. And so you can feel the feedback. There's one thing that you lose the tactile feel on this machine using the handle. All right, you don't really know yet. It's early in the game for everybody here. They don't know what 5 inches a minute looks like. You don't know what 3 inches a minute looks like. All right, so right now we just want to be able to feel the force on the hand wheel. So I'm going to switch back to using the hand wheels to the manual way. So I got to hit the word shift here, the word shift, the button shift, and then Z. All right, you'll see Z manual lights up in the screen. X will be locked. I can't bump X mistakenly. X is locked. Okay, but Z I can move my hand. And we all know what a center drill does for us. We're using them to start our drills. All right, we drill a nice little hole. Okay, to start our hole. Now I gotta warn you, these are the more difficult holes. These 2 holes you need for the crankshaft are the more difficult holes for the whole project, because our fit and tolerance are paramount. All right, our fit and tolerance, we need to make a press fit. We're making a press fit, and the press fit, of course, is crucial. All right. Every other fit we had an allowance. You know, we had to do a running fit or a sliding fit. All of these fits rely on you know, an allowance which gives you motion. Right? This here is a press fit. We need to be pretty much as exact as you could be in this field, as exact. All right, so I start the spindle again and forward. Here I'll make note of my position in Z. I'm at 1/8 of an inch. Good. Pretty easy to do my math from 1/8 of an inch. I need to go in greater than 1/4. All right, I'll go in until I say minus 130 because I was at positive 125. All right, and that's it. You don't want to go real deep. You only need 1/4 of an inch. Remember that. If we go in too deep, we're going to waste a lot of stops for the next student to face off the part getting rid of the hole. Because everybody has to start with a clean bar. All right. Okay. So last but not least, we have the reamer. All right, this, like I said, this is a press fit. So our reamer is 0.248. All right, our reamer is 0.248. I use a 1 drill for my pre-hole. All right, it's a small diameter hole, so I left close to 20 thousandths on the diameter of the hole. I think a 1 drill is down around 0.230, 0.228, somewhere around there. All right. Okay, I start my spindle again. This is a reamer. All right. The reamer will go in and out real quick. Okay. I mean in a slow, controlled fashion. It'll just be quick. All right. Reamer in. Feel it hit off the bottom. And then you remove it. Stopping the machine again. We're done with the reamer. We're actually done with the Jacobs truck. So, last tool on here. This is a parting tool. Okay. Insert on the end. All it does is slice it straight in. All right. So we put this on the machine. I'm going to have you slow this down, slow the machine down a good bit. So if we go to like 100 RPM, all right, that should be good. All right, got to go Shift X to bring back manual operation in X. And I am going to come back to the operator 0. All right, so I'm going to go page up, back to my operator 0, and with this tool, I'm going to grab this camera here. With this tool, you want it lined up so the back edge of this tool is even with the face of the stock, okay? And then we're going to set our 0. All right, well, let's see. Can we reposition this guy here? A little bit of glare, but I think it's got it. Okay, so I am Z origin, oops, Z origin, put my 100 in again, Shift X, Shift Z. I will move Z down so I read minus 250. And I will turn in, slow but sure. Bombs away. There we go. All right. My part is falling off, but I'm continuing the rest of the way to the center to leave the face flat for the next student. Okay. Spindle off. Always taking care. This might be a hot part, depending upon the amount of speed and everything. That's why I have you going that slow. One, it's a new operation. And two, if I spun it any faster, I would generate a lot of heat. Okay? So the part comes off of the machine here. We're done over here. We're going to have to pause. We'll be setting up over at the saw now. Okay, so for the crankshaft, we need to use a piece of drill rod. This drill rod is going to be the actual shaft. Okay? So we're going to saw this drill rod over here on the vertical bandsaw, and we're going to hold it in our vise, and you're going to place 2 inches and 50 thousandths outside of the vise. 2.050. Okay? Simply by using the depth portion of the caliper right into the side of the vise. Our bandsaw blade is cuts a kerf of 0.035. All right, leaving us about 15 thousandths to take over to a grinding wheel, pedestal grinding wheel, and just clean up the edges. All right. Now, when we start the machine, we're going to check the speed of the machine. All right, we're at about 200 feet per minute. That's fine. Now, what we're going to want to do here is make sure that our hand is, let me move this camera here. You don't want our hand to be down overside the left edge, all right, because the saw blade is going to come down. So we make sure our hand is behind that. Notice I got the little tightening rod for the vise sticking out to the left. All right. So if anything, if I slip by there, it comes and hits that. I keep my entire hand off to the back and to the right side. And something that you probably can't see, what the camera isn't picking up, is I take this palm of my hand, and I put it right on the bed of the machine. All right. That'll keep me from falling through the machine when I cut through. Now you're going to let the blade do the work here. We're going to push a little bit of pressure, but let the blade do the work. This is a really, really quick little operation. The only pressure I'm using is my thumb right here. All right? Little pressure. Matter of fact, I can even stop early once I see my blade reaching most of the way through the stock. Okay? All right, because that when it's most of the way through, like I just did, all I have to do is wiggle this, and it breaks off. But that is what we'll go grind off. Okay? We stop the machine, and I'll see you over at the grinder. Okay, so now we're over at the grinder. All right, we turn it on, and here's how you stop it, red button. Turn it on with the green button. Okay? And all we need to do is take off this little edge. And then we're going to want to chamfer it all the way around so you can press it together, give it a little ability to start. Just clean up your edge ever so slightly. All right, both of them. Make sure they're both nice and flat. All right, voila, that's all we're doing here. Now we're going to use the arbor press to press them together. Okay, so we're over here at the arbor press now. I've got a simple tool. It's just a piece of aluminum with a hole through it, which is about 249, 250, which will hold the shaft. All right, and a little recess which holds the disc. Okay, so you can use that. All right, or and actually I don't have one here. I like using a V-block sometimes too. All right, but I don't have a V-block. What I'm going to do here is I'll use put the crank disc underneath there. Putting the shaft in here. The V-block will hold it nice and straight for us. All right. I'll go get that. Use a V-block to hold our shaft down on our part. Shaft tight into the V of the V-block. And I pull down ever so slightly to start it being pressed in. What I do is I like to come up and remove the pressure from the pressed part once to make sure that we're pressing in the right direction. Okay. And then you finish pressing it in. Don't press too far. All right, too hard, because compression can expand our shaft. All right, and there. It's in. Pressed in nicely. Okay, it's tight. Trust me on that one. This isn't computer video magic. It's tight. All right, it's a press fit. All right, we made our hole in here, 248, 249, and the shaft is coming in at 251, 252. So we got about a 2000s press, which is a really, really good press. All right, okay. Any more than that, we would broach. You don't want to broach. All right, we could talk about broaching while you're in the shop. All right, so now we got to go over to the mill and drill the offset hole, which is another press fit. All right, see you over at the mill. Okay, so here we are. We're over at the milling machine now. All right, I'm at the 5th mill. Okay, everybody is, you've been at the first 4 mills. They're staying set up for the other jobs with tools for the other jobs. Here we're introducing this mill here in order to do the offset press hole. This press hole is a 3/16 hole. 0.1875 is a nominal size of 3/16. We'll be making a 0.1855 hole. Okay, all right. The biggest new skill that is necessary to find out where this hole goes on this part is the use of this device here. This device here is called a last word indicator. All right, it's made by Starrett. All right, last word indicator. Still can't see the face of it. Okay, too much shine off of everything. Okay, at any rate, I outfit this mill with a Jacobs chuck. Okay, and I'll put this into the Jacobs chuck. And I don't need to run the machine now. All right, this is just a setup tool. So what I'm going to do is I'm going to simply tighten it in by hand. I don't need it. I don't need to use a chuck key. All right, and then I will use my X and Y axes. Here's the part. Okay, the part on the shaft is going to go into the vise, sitting down flat on top of the jaws of the vise. All right, only tighten up just enough to keep it secure. If you tighten this up too much, you'll take your shaft out around. All right, I'm going to spin the X. I'm going to spin the Y. To what I think is center of the Jacobs chuck. And I'm going to take the last word indicator. I'm going to place it on the OD of the crank disc. Put the machine in neutral. And I'll spin my last word indicator around. The side that my indicator is off the part is the side that I'm most out. So I'm going to go half the distance to it. I reset the indicator and I swing it around again. All right. Now, when the indicator is touching all the way around. I can then begin to read it. We're still off in the back, and I went a little too far in X. So come back to the back, go half the distance to it. I'll reset. Now it doesn't really matter what the number is on the last word indicator dial, just as long as it doesn't move. Okay, so I can read it when I'm trying to set it. So I've got 10 yellow up front. I'll swing it around to the back and see what it's reading. I've got 5 white. All right, so from 10 yellow to 5 white. Right, can you bring that around to the front and just get the front shot? All right, you see that's 10 yellows down there. 5 white is around, halfway around the dial. All right, so 5, 10, 15. I got to come back 7.5 thousandths. So I'm going to come back 7.5 thousandths. So I'm about 4 yellow on the front. I come around the back and I look at it and I see I'm at 0. Okay, so I'm between 0 and 4. So I'm 2 thousandths off front to back now. So I'm going to continue to go to 2 yellow. There's 2 yellow. And I got 2 yellow in the back. So front and back, I'm really good. I'll now work side to side. I've got 3 white on the left side. And I've got 6 yellow on this side. So I'll move this axis now and bring it back to, it looks like it's going to be 2 yellow. So I go to 2 yellow. Got 2 yellow on the right. I've got 2 yellow on the left. I got just about 0 up front here. And I'm down around 4. All right. So because I got it corrected side to side, my front to back is now giving me a different reading, and that's common. So I'm going to go to 1.5. 1.5 yellow. 1.5 yellow. Now, you really can't see this. I don't think you can, but if you notice that dial, I spin this around, and this dial is not moving at all. Okay? You see that? Yes, that's a good shot there. You see that little black needle. Now I'm only going about 45 degrees that you can see it, but you'll notice that that dial is not moving. That tells me that the center of my machine's rotation, the center of my spindle, is now sitting perfectly on top of the center of the machine. So at that point, now it's time to set our digital readout, all right, to 0. All I do is I press my X and my Y 0 right there. X and Y, and they go to 0. All right, I put the machine back in gear. I take the last word indicator out of the chuck. Get a real small center drill this time. Lock it down. Now, there's only 2 ways that you could dial out. All right? There's only 2 ways you could dial out. It's either left or right. You can't go front or back or you'll drill through my vise. All right? The drill will drill once, but as soon as you hit those jaws, it's going to lose. All right? Because the vise jaws are hardened. Okay? So I'll move out 170 thou. I'm choosing to go right. 170. There we go. Start my machine. Small diameter, fast speed. I'm spinning at 2,000 RPMs. Oh, I'm gonna shut the machine off. I need to move my Z-axis. Oh, wait a minute. I said 170. 170 is not right. I got to pause to get the prints. I'm forgetting. Okay, so I went and checked my print. I said 170 before I paused the tape. All right, tape. We don't use tape anymore. All right, we'll pause the video. It is actually 0.370. Okay, so I'm at 370 now. All right, got my Z-axis stop turned down enough. Start the machine. Give myself a center punch. Okay. Stop the machine. Take the center drill out. All right. Taking the drill bit now. Drill all the way through. Nice and carefully. As you notice with this whole part, there's not a whole lot of removal of stock. This is a precise part, not one that you have a whole lot of metal removal. It's more or less all set up. It's all finesse now. All right. Now with the reamer, this reamer we're going to slow it down. We're at 2 grain. We're going to slow down to 1 grain, and that is only because it's got a higher number of flutes, cutting edges. And this will just run straight through and back. Bam. And with that, I am done on the machine. All I have to do is go back to the arbor press and press in the 3/16 dowel. I'm not going to video that one. It's really easy. We can cover it when you guys are here. You already seen the arbor press. All right, but there we go. We now have our offset hole. All right, that our little pin can press into. Okay. All right. See you guys when you get here.